Hello, this is Dr. Mears. Today we are going to learn about the law of logarithms. Before we start, I just wanted to go over parts of a logarithm, which is IB vocabulary, which you'll see in your books and your professors or teachers use it. So first we have log base A. So this is called the base. This is going to be the power, and this is going to be what's called the argument. If you would like to think about it as the answer, you can too. Now, how did I get those parts? Well, remember, when we undo a log, when we take the inverse of a log, it's actually going to turn exponential. So we're going to do base A to the power of y equals x. So here we see the base A, power of y, argument or answer x. There we go. Okay. The laws and their use. Law number 1. If we have the same base and we're adding, then we multiply the arguments. Notice I have a double arrow. That means that if we're multiplying the arguments, I can go back and I can put them into same bases and add them. What does this mean? Well, we're really expanding and contracting. That's how I like to think about it. The expanded version of a problem is going to have more than one log in it. Same base though. This is supposed to be an A, everybody. That is supposed to be an A. Okay. Or we can contract it. This is the contracted version, the version that is a little bit more simplified. So instead of having 2 logs, we have 1 log. And make sure that you changed it in your sheet. It should be that. Okay, example number 1. Write as a single logarithm. So we're going from an expanded version to a contracted version. So we want only 1 log. Notice, do we have the same basis? Yes, we do. So we can write log of 8, base 8. Now what we're going to do is we're going to take the 6 and the 3, and because we're adding, we're going to multiply them together. So 6 times 3 is 18. So it comes out to be log of 8 with an argument of 18. So this came 6 times 3. That's how we did it. Example number 2. If x equals log base 8 of 6 and y equals log base 8 of 3, write the expression log base 18 in terms of x and y. So first, let's write out log base 8 of 18. Well, what did we do to get this 18? We took log base 8 of 6 and we added log base 8 of 3, which is what we did here. We are now going from a contracted version to an expanded version. Now, if log base 8 is x, this is x, and log base 3 is y, that's y, we added them together. So our answer is just going to be x plus y. That's how we write it in terms of x and y. So the first thing that we did was we looked at 18 and we said, okay, what can I do with 6 and 3 to get 18? And you notice, well, 6 times 3 is 18. That times really turns to that addition. We wrote the 2 logs, log 6 and log 3. When we add those logs together, x plus y, we get back 18. Okay, let's keep going. Let's try another example. Law 2. Same base and subtracting, we divide the arguments. And vice versa, if we want to divide the arguments, we go back to the same base. So again, here we have an expanded version, here we have a contracted version. So let's see what they want us to do. Write as a single logarithm. So they want us to go from this expanded version down to the contracted version where we go from 2 logs to 1. So what do we have subtraction here? If we have subtraction, what are we going to do with the 12 and the 3? Yes, we're going to divide them. So this is going to be log base A of 12 divided by 3, which equals log base A, 12 divided by 3 is 4. Yay. Okay, example number 2. If x equals log base 5 of 12 and y equals log base 5 of 3, write the expression log base 5 of 4 in terms of x and y. So here we have the contracted version and we need to separate it. So we're going to do log base 5 of 4. I always like to write down the original here. All right. What do we do with the numbers 12 and 3? Well, what we did was we divided 12 by 3. So that's log base 5 of 12 divided by 3. What does this division mean? This division means that we subtracted log base 12 minus log of 5, log base 5 of 12 minus log base 5 of 3. Because that's division is minus. All right, sweet. So how do we write it in x and y? Well, what's x? Log base 5 of 12 is x. What's y? Log base 5 of 3 is y, and we subtracted them. So this is our answer in terms of x and y. It takes some getting used to. Really, you want to look to see what did I do to these two numbers to get to this one. So 12 divided by 3 is 4. Okay, let's do another example because it doesn't necessarily have to be x minus y. Let's see what happens here. If x equals log base 5 of 12 and y equals log base 5 of 3, write the expression log base 5 of 1/4 in terms of x and y. So let's write down log base 5 of 1/4 equals log base 5. All right, 1/4. So what did I do to these numbers to get to 1/4? Well, if I divide 12 by 3, we know that's going to give us 4. Well, what happens if I divide 3 by 12? And sometimes I like to do side work. Well, 3 divided by 12, if I reduce that fraction, 3 divided by 3 is 1, 12 divided by 3 is 4. Ooh, so I actually reversed it. So log base 5 of 3 over 12. So let's expand that out. Log base 5 of 3, this is division, so minus log base 5 of 12. Okay, what's y and what's x? Log base 5 of 3 is y, log base 5 of 12 is x, and I subtracted them, and this is your expression in terms of x and y. So it's really looking, what am I doing to these numbers to get to our final answer? Okay, the next law. Log is being multiplied by a number, p times log base a of x. Raise the argument to that number, log base a of x raised to the p. So what happens is this p goes to the exponent position. So example 1, write as a single logarithm. Now notice, here you don't see a base, we see 3 log of 5. The base of 10, remember, likes to hide, and that's also in your calculator. Remember, if we have log here, that's really log base 10. So remember, that 10 likes to hide. You don't have to write it. You just have to know that if there's no base given, it is base 10. Okay, so write as a single logarithm. We have a number being multiplied by a log. So this 3 is going to come up to the exponent position. So this is going to be log of 5 raised to the 3rd power. Can you go on? Yes, we could do log of 125. 5 times 5 times 5 is 125. Okay, next example. There we go. If log base 2, if x equals log base 2, and y equals log base 5, log of 5, let me start over. That was tongue twisting. If x equals log base 10 of 2 and y equals log base 10 of 5, remember those base 10s like to hide, write an expression log base 40 in terms of x and y. So here's the thing. What do we have to do with 2 and 5 to get to 40? Well, if we multiply 2 times 5, that's 10. We got to get to 40. We know we're not going to divide because dividing just gets us a smaller number. So we're actually going to have to maybe bring a power into this because remember, our law was about powers. So I'm wondering, what number times 5 gives us 40? Well, you're right. 8 times 5 gives us 40. Okay, well, I don't have an 8 here, but can I change something so that I have an 8? What can I change into 8? Can I change a 2 into 8? What do I have to do? You're right, I can raise the 2 to the 3rd power. 2 times 2 times 2 equals 8. So actually, I can say we have to take this log base 10 of 2 to the third power. That's okay. And I am going to multiply that by 5. So this is really 8 times 5. Remember, 2 to the third is 8 times 5. That's how I can get to my 40. So from there, what I can do, what happens? Well, I have to expand this out. So I have log 2 of 3. I'm multiplying, so it's going to be plus log 5. This 3 is now in the exponent spot. We don't want to multiply it out. We want to undo it. We want to make it, we want to expand it. So I'm going to say this is 3 times log 2 plus log 5. What does that look like written out? Well, let's find what x and y is. This is going to be 3 times log 2 is going to be our x, 3x, plus what's log 5 is y. So sometimes you're going to have to use a little of your math skills to find how can I manipulate these numbers in order to get to that answer. And yes, you might have to use a power. And that's why I did this example, to show you, you might have to use one of these numbers and raise it to a certain power in order for us to get here. So that is a little problem solving. Okay, let's see. Next, last law, number 4. Base is raised to a log of the same base. Let's look to see what that looks like. Base A is raised to log base A of x. The answer is the argument, x. Oh, this helps us to find exact values. So let's say we need to find the exact value of 7 raised to log base 7 of 4. Well, this is just going to be 4. That's it. That's it, everybody. This really drops out to 1, and 1 times 4 is 4. That's it. Yep. Moving on to further examples now. Further examples. Example 1. Use the law of logarithms to write its expression as a single logarithm. So the reason why I'm doing further examples is because I haven't showed you where you did an activity, but what happens when we have the number 1, because we don't have 2 logs here. Remember, when we were writing them as a single, we had when we write them as a single, we have 2 logs, but we don't have one here. So the first thing that we need to do is we need to change this number into a log. Now, I just said for this one, this was really 1 times 4, which gives us 4. So how do I change 1 into a log? Well, 1 equals, first, let's start with a base of 7 right here. See how that is a 7? We need same base to do anything. So log base 7. Now, what happens? This argument also has to be a 7. So anytime you have log base A of A, that is going to equal 1. Yay. So what we could do is we can replace this log base 7 of 6 minus log base 7 of 7. This really represents that 1. So we have subtraction. How do we write it as a single one? Subtraction is what, everybody? You got it. Division. So this is log base 7 of 6 divided by 7. And that's it. You're done. Okay. Part B. 2 log base, remember this is a 10. I'm going to fill it in, of 5 plus 2. Okay, so we know we have to change this to, well, we know that log of 10, base 10 of 10 equals 1. Well, how do I get it to be 2? What do? I want to do 2 times 1. Well, this represents 1, so what am I going to do? Yep, I'm just going to multiply this side by 2 as well. So here we have 2 log base 10 of 5 plus 2 times log base 10 of 10. Okay, let's take care of our exponents. So this is where using these laws come in handy. So these powers are going to go up there. Yay. So this is going to be log base 10 of 5 squared plus log base 10 of 10 squared. Can we do them out? Let's do them out. Log base 10 of 25 plus log base 10 of 100. We still need to write as a single logarithm. We have addition. What is addition? Addition means that we're going to take these two numbers, 25 and 100, and multiply them together. Remember, addition is multiplication. Really reminds you of exponent rules. Same base, and we're multiplying, we add the exponents. Same base, we're dividing, we subtract the exponents. Same concept. We're just applying it to logs now. So this is going to be log base 10 of 2500. A little bit more work. You have to understand this rule, and that's why I went to do further examples with you. Okay, last two further examples that we have here. We have log base 12 plus 6 log base 2, log of 10, log of 10. Let's put that in because I just read it not right. Log base 10 of 12 plus 6 log base 10 of 2. I know you like filling things in, so we can fill that in. So what do we have to do here? We have to get it to 1 log. All right, so first take care of your powers. That's number 1. Take care of powers. Okay, so let's write log base 10 of 12 plus log base 10 of 2. It comes up to the 6th power here. Okay, then number 2, we can simplify those powers. So we need 2 to the 6. So we have log base 10 of 12 plus log base 10 of 2 to the 6, I believe is going to be 64. So remember, that's 2 times 2 times 2 times 2. 2 times 2 times 2 times 2 times 2 times 2 equals 64. Okay, next, number 3, we're going to look to our laws. Use a law. Use some laws. All right, what are we doing here? We're adding. We have same base. When we're adding, what do we do with these numbers? Absolutely right. We're going to multiply. 12 times 64. So we have a log base 10 of, I'm going to multiply 12 times 64, 768. Perfect. Yay, single logarithm. Remember, we're going from an expanded version down to a contracted version, and that's how we started our lesson. And let's look at the last further example. Notice I now have 3 logs, same base, base 10, base 10, base 10. I went from 2 to 3. It's okay. We're just going to take it, we're going to move it from, we're going to look at this problem from left to right. All right, everybody, just like we read a sentence. So the first thing, let's see if there's any powers to take care of. So if there's any numbers in the front. So we have log base 10 of 6. Nothing in front here. Okay, that's actually a 1, which we don't have to worry about. Plus, oh, look at this. We got to move this over. So this is going to be log base 10 of 3 raised to the 3rd power. Okay. Oh, there's a 1 there, so we don't need to worry about that. Minus log base 10 of 2. Okay, let's simplify our powers. So log base 10 of 6 plus log base 10, 3 to the 3rd is 27, minus log base 10 of 2. Now we have to put it all together. We have to use some rules. So first, let's left to right. Let's use my addition. So log base 10 of 6, what's addition? Times 27, okay? Minus log base 10 of 2. So addition turns to multiplication when we contract them. Then, what is this minus? That means division. Think of it like that. Log base 10. I'm doing now 6 times 27 divided by 2. Let's see what that is on the calculator. Clear. So we could do, I'm going to actually do 6 times 27 divided by 2. 81. So our final answer, simplified, is log base 10 of 81. All I did was 6 times 27, and then I divided it by 2. And if I did this, I did 6 times 27 with parentheses in my calculator because that was the first thing that we did here. You have to make sure you do that. We could have also just multiplied automatically here. So if you wanted to, this is 162. If you actually wanted to get that number at that step, you can, or you can save it for last. This has been Law of Logarithms and further examples. Hope it helped.